Greetings, everybody. Today we're going to look at arithmetic series and sigma notation. Arithmetic series is the same as summing up the terms in a sequence. Sigma notation is the way that we write that summation. So let's look at an example that we have here from history. We have a mathematician, lived in the 1700s and 1800s, Carl Gauss. The story goes, as a child, he was given the task of adding the first 100 integers in school as busy work. I'm sure the teacher thought it would take him a few minutes to get through that, considering he was an elementary student. He came to a very clever solution, and we're going to start our discussion over arithmetic series using his example. And we'll actually call it Gauss's formula once we define it. So here was his task. He had to add 1 plus 2 plus 3 plus 4 and so on, all the way up to 100. And you can imagine that might take an elementary kid a little bit to do that. We're going to look at his genius here and why he was immediately kind of identified as being pretty bright once he figured this out. So here we go. So we're going to start with looking at the first and the last term and figure out what they add up to. And if we look at that, that's going to, of course, add up to 101. Okay, now we're going to look at the second term and the second to last term. And what does that add up to? 101. So this is what he saw, the pattern he saw. And if we look at the third term, and the third to last, 3 plus 98, again, is 101. So he saw that every pair, given this kind of structure, adds up to the same number. And so he thought about the number of pairs that it would take to get this sum. So if we think about that, we have 100 numbers, and if we pair them up, that makes 50 pairs. So he just did 50 times 101. Okay, of course, that's going to give us 5,050. Of course, he returned his answer within seconds, apparently, which did not go over well with the teacher, I can imagine, as he needed to find something else for him to do at that point. Let's look at how we're going to turn that into a formula here. So we're going to look at what we call Gauss's formula next. So this is what we call a partial sum, where we're going to add up the terms of a sequence. Our last sequence dealt with the integers 1 to 100. To find the partial sum, you can use the formula Gauss is credited with. Here are the pieces. So let's just kind of break down what all these pieces stand for here. So as we look at these different pieces here, this S of n over here just really indicates the sum. Now, in Gauss's formula, we did sum of 100, right? Now this n over here, that represents the number of terms that we're adding. And of course for him, n equaled 100. And then right here, a1, that's going to be our first term, as we know already. And the notation on this is a little bit unfortunate because it doesn't really indicate the last term like a1 indicates the first term. But just remember that this number right here is going to be the last term of the sequence. And for his case, that was 100. Okay, so we're going to go ahead and use Gauss's formula next to find the sum 5,050. Just on a side note, this formula only works for arithmetic series. This will not work with geometric series. We'll get to that later. Okay, so here's what Gauss's formula looks like with numbers plugged in. So we're going to start with S of 100 because we want to find the first 100 terms added together, the sequence. And we're going to say 100 divided by 2. And then we're going to put the first term there, which was 1, and our last term, which is 100. So looking at all those pieces, just on a little note here, just out of interest. So this piece right here, 100 divided by 2, of course, that always stands for the number of pairs that we're adding together. N is the number of terms, but when we divide that by 2, we get the number of pairs. It's kind of like if you have 100 socks in a drawer and you pair them all up, how many pairs of socks do you have? You have 50 pairs. Okay, so we have everything plugged in here. Of course, we need to do our parentheses first. So as we look at that here, we're going to go ahead and do and we can go ahead and do this 100 divided by 2 as well. Of course, that's going to be 50. So S of 100 equals 50 times 101. And we can see right there, there's where he came up with his formula there. That gives us our 5,050. So you can take a shortcut, thanks to Gauss. You can use his formula right here. He did the work for us. Okay, now we're going to look at an example. It's a little bit tougher because we're not given the last term. In this example here, we're given the first term, a1 equals 4, and the common difference is 5. And we're asked to find the sum of the first 10 terms of the sequence. Again, we don't need to find all the terms of the sequence to add them together. We just need the first term and the last term. But as we look at this, we don't have the 10th term. So we're going to build on what we did the other day, or whenever you did that, which was how we find a term of a sequence. Well, if we're looking for the 10th term, we're going to use our what we call our explicit formula here. And we're going to plug in what we're looking for. So before we can even start on the sum, we need to find A10. So what we're looking for is, what is A10? Now don't confuse that with S10. Okay, S10 is the sum of the first 10 terms, whereas A10 is the 10th term of the sequence. All right, so let's go ahead and find the 10th term of the sequence, and then we can plug it in Gauss's formula. Okay, so A10, remember, we're just going to, left side just indicates we're looking for the 10th term there. And we're going to put in A1, which is 4 in this case. And we're going to plug in a 10 for n. And then our common difference. And I normally put that in parentheses. Our common difference is 5 here. Okay, then we're going to follow our order of operations. Remember what we're going to do. We're going to find 10 minus 1 first. So that's going to be 9. And 9 times 5 is 45. And 45 plus 4 is 49. So the 10th term of the sequence is 49. Okay, so we'll write that over here so we can kind of keep that off to the side there. So A10 equals 49. And we'll use that in our summation formula here in just a second. Okay, so now that we have A10, we can go set forth and use Gauss's formula. And we're finding the sum of the first 10 terms. Okay, so we're going to have S10. That's what we say. And of course, n is the number of terms we're adding together. And we're adding 10 terms together, which makes 5 pairs of terms. We put our first term here, which is 4, our last term here, which is 49, and then we just follow our order of operations. In this case, we have 10 divided by 2 is 5, and over here in parentheses, we have to do that first, is 53, and S10 is 5 times 53, and 5 times 53 is 265, so we'll say S10 is 265. That's the same if we had added 4 plus 9, each one of these grows by 5, plus 14, and so forth, all the way out to the 10th term, which is 49. And these would be pluses in between. So that's the same work as adding up 10 terms. Notice it's a lot shorter, and there's our answer. Okay, our next piece that we want to look at is how do we write a summation without having the sequence? What if we just have the rule for the sequence, but we want to calculate that summation? So this is what it looks like in mathematics. Now, this is a nice formula. I always feel like when I teach this, kids feel like they're getting smarter as they're learning this formula right here. Typically, when you see movies or shows, they will include some form of sigma in their chalkboard equations that they put behind the smart mathematician or whoever it is working. So once we understand this, it's not really that difficult. So sigma is this Greek letter here, and sigma starts with an S. So when you think sigma, I want you to think sum. S stands for sum. Sigma, sum. So that just means that we're adding up the pieces. And in this case, they tell us the formula that we're using, and they tell us where we're starting, which term we're starting with. We're starting with the first term, and we're adding all the way up to the 4th term. So let's go ahead and look at an example on how that plays out. Okay, so we've got this example here. Sigma index, the lower index of summation is 1. The upper index is 6, and the rule we're going to use is 2j minus 3. So here's how we're gonna look at this. We're going to generate this sequence by using our rule. Now I'm going to write out the first couple here, but I'm not going to write all of them out. Here's how we find our terms. So the first term of the sequence, okay, this is n, a of n. The first term of the sequence comes from this. We're going to use a1 for j. So 2 times 1 minus 3. That's going to be negative 1. And then find the second term. We're going to plug a 2 in there for j, and we're going to get this. 4 minus 3 is 1. So right now what I'm doing is generating the sequence. So we have negative 1, comma, 1. And of course this goes up by 2. We can see this comma difference here is a 2. So we're going to be increasing by 3. So at this point, we need the first 6 terms of the sequence. So we have a 7 and then a 9. Okay, so that's the first 6 terms of the sequence. And what do we do with those? Well, we add them together. So it's negative 1, plus 1, plus 3, plus 5, plus 7, plus 9. And that's going to give us what we call S6. Okay. Of course, if we add up all those pieces, what we get is 24. So that's our final answer. Now there is a calculator trick you can use for this. I'm going to show you what it looks like on the in terms of instruction. Okay, so you can do that. That's kind of tedious, you can see, and especially if we had to add up 30 terms. Last time we just did 6 terms. If it was like 30 terms, it would take you a really long time. So there is a way that you can do this on the calculator. It looks like this. If you go to your math button and then scroll down to where it says summation, and what will pop up on the screen is something like this, and there'll be a blank spot where the variable is, a blank spot where the 1 is, and a blank spot where the 12, and there'll be a blank spot for the rule. And on the calculator, we want to make sure you use an X there. Use X as summation on the calculator. So looking back at the last example, you would literally just plug this into the calculator. You would plug in 3 pieces here. Let me circle those here for us. So you plug in an X there instead of J. You put a 1 in that spot, a 6 in that spot, and then put your rule in here in parentheses. And I would show you on the calculator right now, but my free trial has run out on my digital calculator. So I'll get that reloaded as soon as I can get that purchased and be able to show you on the calculator. And I'll show you in class if you need it. Hopefully this video helps you kind of think about series and summations. Again, back to the name of the title here, Arithmetic Series and Sigma Notation. Have a great day.